welcome to a new episode of PC Voyage. I'm Diana McLean.
And I'm Rainey Laviolette.
And today we're going to talk about how to build your own PC with Glenn Trim.
And Ernie Savoy.
But first, we're going to talk about visiting the site, Cigna Insurance.
I understand that we had a crew went down to see how their PCs tied into their mainframes. Field producer Glenn Trim went down with Bill O'Leary, and Ernie Savoy was also down there. And
there was someone that interviewed. You can remember, right?
I wasn't there. Was it you?
It was me,
oh,
yes.
Geez.
And I enjoyed it a lot. It was amazing, the technology at Cigna.
Lots of PCs spread out all over the place.
Everything. It's unbelievable, and you'll get to see it right now.
Hello, welcome to Cigna Corporation's Windsor Processing Center. I'm Diana McLean, and I'm here today with Ernie Savoy.
Hi.
Ernie.
Hi. Welcome.
Well, thank you very much. Now tell us, what are we doing here? What does this have to do with PCs?
Well, this is a traditional data center. In view of people's mind, it's a big building out somewhere that people don't know a lot about, and it's got big machines sitting inside called mainframes, and they don't understand that the mainframe that I have sitting out on the other side of our secure wall here, which we'll go to in a few minutes, and the PC sitting on their desks are basically the same machine. The biggest difference is in quantity of scale, and we'll see that. But the interesting phenomenon that's been happening in this industry, this is Cigna's an insurance company, and a lot of other large-scale industries that use mainframes, is the advent of the PC has meant a redirection in the way we think about processing, the way we think about computing, and the way we do our jobs. In this data center alone, over the last few years, we have supplemented work first, and with PCs, having people do multiple tasks on PCs, and now we find that the PCs are actually beginning to pick up traditional mainframe loads, and the mainframe, from being a number cruncher that we couldn't get away from before, is now becoming just a great big LAN server. We get information through it, but we're not using it to process information anymore. We're doing that sitting right on our desk, the same way that people at home in the audience do their spreadsheets, do their word processing. We process insurance applications the same way, using the same CPU. So traditional data centers, as you know them today, or traditional mainframe data centers, are basically going away.
Well, maybe we can see some examples of the type of hardware that you have here.
Sure. We'll take you out on the other side of the wall, and we'll show you how we operate not only this data center with PCs, but we also manage our remote processing centers because of the advent of PCs. We used to have people staged all over the country. We no longer have to do that. We can run from a centralized location, and it doesn't have to be here. We can basically pick up our operations staff and move them anywhere in the world and still manage this data center. And it's all because of that little PC sitting out there on somebody's workstation.
That's truly amazing.
So, why don't we go look?
Sure. So where are we now?
This is the Master Console Operations Center. And what these folks are doing right now is managing the CPUs, the mainframe images, across all of Cigna's corporate processing centers. And to translate that, what that means is we're here in Windsor, Connecticut. We have two groups of mainframes here, and they're monitoring all of those images. That's 4 images in group 2, 3 images in group 1 in this environment. And they're also managing and monitoring our systems in Thornton, Colorado. That's 1,800 miles away up in the Colorado Rockies. And what they're doing, or the reason they're able to do that, is because of PCs. If you had come just to this data center a year ago, you would not have seen all the PCs. What you would have seen was over 50 terminals just to monitor and manage this environment in this data center. With the advent of the PCs, 2 things have happened. One, as we scan over here, you can see the PCs are broken up into multiple quadrants, and each quadrant represents one of the screens that we used to have a dumb terminal for. So the people basically have 4 live sessions plus a DOS session that they can manage the environment for here. The other thing that's happening is in Colorado, hooked up to the mainframes are PCs on each mainframe to communicate with PCs here, which allow us to send commands that normally you would have to be locally to that mainframe, and it will process it just like the person was there instead of 1,800 miles away. So basically it's unattended operations.
I see. I have to say it does look like Star Trek.
Well, if you'd been here a year ago, it would have looked even more so, because all you saw was terminals. And now what you're seeing is basically one operator, Donna, sitting down there looking at 13 major CPU images and the processing environments for all of those. And all the monitoring tools, which are these terminals here, she has direct access to, and she can work on them. She doesn't need to have a terminal session on a dumb terminal every place that she needs to look. She can jump from one to the other.
So, I can't believe how many PCs and computers there are on this facility.
Well, we're going to show you some more, believe it or not, because what you're beginning to, I hope, to get a feel for is that what people traditionally thought as a mainframe data center or a network hub, which is also what Cigna is, that what you're seeing here is more and more PCs taking over tasks that used to be very, very expensive to manage with both manpower and equipment. And now we're seeing basically the same PCs people have at home doing those jobs. Behind us is a good example. Cigna owns or leases thousands of miles of lease lines through the different telephone companies across the country to manage our network. We have field offices where people are entering claims, processing your insurance information. And what we've done is begun to use bridge technology, PC LAN bridge technology, to one, save on costs, and two, better manage that. And what that technology does for us is there are PCs out in the field. There are people process too, called big servers. And what the servers do is they're bundling all these groups of transactions that they're processing and folding them into great big blocks of data, which then the bridge takes up and throws out on a token ring. And what the token ring does is, instead of having to buy this huge lease line dedicated to one office, it allows multiple offices to use the same lease line and bring all that information back here to either be processed or to be stored downstairs on our DASD. DASD is disk storage to people who don't know the data processing term. So, as you can see back here, there are literally several dozen PC screens, each one of those representing specific sites that are sharing rings, token rings, the same type of token rings that you read about in PC Magazine or that you see advertised in Computer Shopper. Ethernet is another utility that we use here. So there is a lot of LAN technology at Cigna also, and again, that's all PC based.
Wow, I can't believe the size of the mainframes.
Well, as you can see, and we're only seeing a small piece of it here behind this glass partition, that these things are rather huge. Just in size, this takes up the approximate floor space of all the people that manage it take up, to give you an idea. Not to say that that by means is the only consideration you have to have for a mainframe. You also have to have massive amounts of cooling in this building, and we do that with chilled water plus the electricity it takes to run it. And we can do the same amount of processing, not in today's world yet, because we have to rewrite applications to do it, but with a few hundred PCs. The 486s will definitely give us the same MIPS, a million instructions per second, if we tandem them into processing environments that these traditional mainframes have. And that's the experience that we're learning out in the fields. Less and less of our applications are being written for this type of environment, and more are being written to be worked at a workstation. Again, this guy is handling the transfer of data from storage downstairs to the workstation across the bridge or across our network out to the field, but the actual work, the modification of the data, is being done at a PC. Well, these are what we've been talking about as dumb terminals, and we're in a tape library where people are mounting up tapes that are transient storage. Transient storage means similar to what your floppy diskette would be in a PC environment. You're going to put information on that you don't want resident always on your machine. Well, we use literally 500,000 volumes of transient storage in this data center alone. And I brought you down here to look at these workstations to show you that PCs haven't replaced everything, but even traditional workstations where we still have to keep them, people will come up here to respond to messages. They're not using them to do their job in mounting tapes, which is what the librarians here are going to do. They're using the large screens, which we'll show you in a few minutes, that are mounted all over the place, and that are tied into PCs that are monitoring every message coming off the mainframe and redriving the messages that are only relate to this job. So these people don't have to scan hundreds of thousands of messages to figure out what tape mounts have to go where. Their tape mounts are being filtered for them by a PC, and it makes their life easier. So why don't we go look at that?
So these are the PCs called Tape View that allows users not to have to look at the screen.
That's right. As you can see here, we have different tape view screens, and all you're seeing on them, the first digits that you see are the addresses of the physical tape drives that these people have to find on the floor, and there is quite a few of them. And then the actual tape by volume number, and you notice those are 600,000 ranges. Those are real numbers that they have to go back in our library, which has a couple 100,000 tapes on site, find those tapes, come out here and find a drive and mount the tape. Now, even this across the room is hard to see, but when you translate that into the terminal that they're looking at, which is hanging up here in the ceiling, you can see what we're talking about here, that they no longer have to go to a dumb terminal.
Well, we're going to let Ernie get back to work with all his computers here at Cigna. Thanks, Ernie. And this is Diana McLean for PC Voyage.
Hi, welcome back. I hope you enjoyed that. It was quite something.
I think that was great, and all the PCs all over the place. Is there anything that was very memorable about
Well, it's interesting to note what it takes them seconds to accomplish. It used to take people many years to do.
That's amazing. That's amazing.
It
Probably
is.
over 100 years, huh?
Could be.
Do they have those things that, suck the panels off the floors?
Oh, my favorite. Yes. Well, they have hollow floors because of the cables and everything. They need access to them. So one of the things they had was the suction that pulled up the tiles.
You're literally walking on rows of cabling and everything, miles of
Yes.
cabling underneath these buildings.
Feeling like you're walking on space half the time. It was quite something,
If you really knew,
if you really knew.
Well, what we're going to do now is Glenn Trim and Ernie Savoy have put together a series of instructional segments on how to build your own PC. And we're calling the segment This New PC. If you're thinking about building your own PC, or you want to learn how to repair PCs, this might be the right segment?
I think it will be. And even, yes, it will be.
Oh, good. Go ahead, take it away, guys.
Hi, my name's Ernie Savoy,
And I'm Glenn Trim.
and this is This New PC. Tonight, we're going to start a series of programs here on PC Voyage to show you how simple it is to actually get into a machine and either upgrade it or build one from scratch. And in this case, we're going to build one from scratch. And we'll talk about what we're doing as we're doing it, and we'll show you what we're doing while we're doing it, so you'll get a good feel for what's going on. Glenn is going to be taking care of most of the parts here, so why don't we start out with telling them what type of machine we're going to build.
The machine we're going to be building is a 4633, and it's an Intel chip. The main motherboard is in this bag, and we'll take that out as we destatic ourselves. One of the points that we'll make frequently throughout the production here is that we take care of the static in our hands before we handle any of the electronic components, something to remember very, very frequently. The tools that we're going to need are very simple tools: screwdrivers, surgical forceps if you get them, or a pair of tweezers, a knife to cut open the packaging, which obviously has been done in most cases here. What you won't need is you won't need something like this. This is a little overkill for anything we're going to try. So we're going to be able to do this, Ernie and I, and with just a tabletop space and the components. And you should have made all your decisions about buying, which we have already, and decide which components you're going to use, what type of chassis, and what type of board.
One of the things we decided to do at the beginning of the show is because Glenn and I have always had an on-running debate about which is a better format to go with, either a tower case or a desktop case. My preference has always been a desktop case because I have room. I have a lot of room to do things like that. Other people, on the other hand, don't. And so there are distinct advantages to going with a tower case. As you can see, it doesn't take up a lot of room. All your controls are basically in the front. You have your exposed drive bays for things like floppy disks, CD-ROMs, tape backups. And there's bays inside for hard drives, which you don't need to see. One of the disadvantages, and we'll slip the cover off and we'll show you that, is that instead of the motherboard laying flat, the motherboard is going to go in vertically. And what that's going to mean is every time you want to change something, every time you want to do something in the case, you're going to be working against gravity. Okay, you're also going to be working with cables always wanting to fall down over the work that you're doing. So one of the decisions that you have to make is, if you need to sacrifice room, how large a tower case sacrifice for them. How large of a tower case you want to go with, and is that really a viable option, particularly if you're not comfortable. I'll get this out of the way, and we'll show you why, at least I think, a desktop case, even a small one like this one, has advantages as opposed to a tower.
If you do need a lot of room and you find that you need a lot of components, the towers do come in 3 sizes. A small one would be about this size, a medium tower is what we saw here, and a large tower would be even taller than that with more drive bays, essentially, because the actual working space inside the cabinet is about the same. This cabinet comes with a top that comes right off. Everything is isolated for radio frequency interference, so that all the noise, the electronic noise, stays inside the cabinet. And if you look at the layout of that machine and the layout of this machine, if I stood it on edge, it's just about the same thing. Everything's pretty much in the same place.
Okay. Now, again, going with the advantages in this case, and I'll stand it up this way, which is be more orientated the way you'd see it on your desktop looking down into it, you are going to be placing your motherboard in here, and as we place the motherboard, you'll see how we connect the screws up on it. And then your cards will basically, once the machine is flat, just press straight down in. And again, now you're not working against gravity, you're working with gravity. In placing the cards, and also with your cables, you always know where their orientation is going to be. They're not going to be falling over the work that you're doing. You will see that there's a lot of cabling that comes in a case. There is power that goes to the motherboard, is usually 2 plugs. And then you have cabling that goes to things like floppy drives, hard drives, CD-ROMs, tape backups. And they have different types of connectors, and good cases and power supplies basically will give you a selection so that you don't have to go out and get adapters. The last section of wiring you'll always see in a case is connectors that go on the motherboard themselves. In this case, you have connectors for the lights that go on the front, your LEDs. They'll show you whether you're in high speed or low speed, whether power is actually on in the machine.
Whether the hard drive's operating.
Yeah, hard drive's operating. Then you also have a key lock, so you can basically disable keyboard or the motherboard itself with the turn of a key, and a power switch light. So.
Inside the chassis, when you buy one of these, you're going to find a power cord, any separate special cords that you're going to use for the installations, and a box full of auxiliary parts. This one comes with slide rails for the drives, all the screws that you're going to need, and everything's in a bag here, so we won't lose anything. We're going to keep it right where it is.
And as always with electronic parts, you're going to end up with a bunch of little bags that's going to absorb moisture. You can just discard those as you take them out of your cases. So why don't we get started here. We'll unwrap our motherboard. Now, we talked about static. Glenn is putting his hands in the case, and what you want to make sure you're doing is that you are, in fact, at the same electrical impedance and register as the case is. So what he's doing is he's taking a couple seconds to discharge any static electricity that he's built up by walking around. You can get a static strap if you can find one at an electronics store, but this is the easiest way of doing it. Whenever you take the cover off your machine, always put your hand on the power supply before you touch any componentry at all. That way you're always sure that you are at the same resistance level as that machine and you won't discharge static.
All metal components inside the machine should be grounded and should be at the same electrical impedance. But in the event that they aren't, the power cage is the one that you're going to look for to touch. So just touch the outside cage of this. There is no electrical power in it, even if it's plugged in, so there's no danger.
One other thing you can do while Glenn's unwrapping that case, just to make sure, is when you are shopping for cases and power supplies, they cost a little bit more, but always make sure that you buy a power supply that has been reviewed by Underwriters Laboratory. There's 2 very, very good reasons for that. One of them is meeting all American standards, Glenn on our side, and the other piece that you'll see when you're reading this is a lot of insurance companies, if you are going to get a policy for your home to protect your equipment, are going to be looking for an underwriter certificate. If anything does happen within the home, particularly if there's a fire, an electrical fire, they're going to be looking for that. So it's always a good idea to make sure that you have some type of clearance that is recognized in the United States by either OSHA or the electronics and the insurance industries as being a safe unit.
Now, a couple of the things we want to point out on the motherboard that you want to be looking for. This particular board has a series of expansion slots, and we have 2 8-bit slots. Those are the shorter ones. These longer ones that are not quite double length are 16-bit slots, and the 3 long ones here with the extra extensions are the VESA slots, the local bus slots. Now, this board is set up, it's quite a high-end board, and you're going to find that you probably could get away with something less for a home, but we decided to go top end here because that is going to allow us to be expandable through many years into the future. The memory chips are, in this case, SIMs, single inline memory modules, and they plug right into this bank here. We have 4 1 meg chips in now, and we have space enough for another 4. And this particular board will handle 4 meg chips as well, so we could go to a total of 32 megabytes of memory. We decided to start off with just 4 because that is adequate for the home system. The chip mounts in here, and this hand lever it's a zero insertion force slot, a ZIF slot, and this can be taken out. And this particular motherboard will also handle a Pentium chip. So if at some time down the road we decide to upgrade, we don't have to replace the entire board, just a chip. This bank of chips here is our cache memory, and you want to try and get at least some caching on your board when you buy it. The more the merrier, because that's going to allow you to increase your speed of operation in a lot of functions.
Okay, so now that we are both discharged, I'll move the wiring out of the way, hold the case up a little bit. And what Glenn's going to do is he's going to first orientate the board front to back. And what we did ahead of time is we have put some risers on the motherboard because not all the screw holes will line up with every motherboard. They provide as many configurations within the case as possible. But in this case, Glenn and I thought it would be, because we are going to be plugging cards into this motherboard, and we did not have good support within this case down on one end of the motherboard, that we decided to put these extra risers in. They're nylon, they cost about $0.05 a piece, and you can get them at most electronic stores like Radio Shack or at computer shows, or through mail order when you order the case. They'll come with them.
The orientation of the board when you put it in is very obvious. This big plug on the back is where your keyboard plugs in, and there'll be a round hole in the back of the chassis that lines up with. Now, whether it's got clips or whether this board has screw holes and standoffs that it has to deal with, it has to be mounted into the chassis in a particular way. This one has a clip, so you'll hear it snap in place.
Glenn is being extremely careful at this point because the last thing that you want to do is cause a crack in the motherboard. And the reason I say that is if you notice the size of this motherboard, I'm going to stand this up for a second here. It's very small in compared to what they were even 2 years ago. And the way they've accomplished this is a lot of the circuitry and components that used to be on the motherboard, they now put in layers, electronically stamped, on the board itself. So you have anywhere from 3 to 5 layers. It means you have to be a little bit more delicate than you used to in installing these things, but it's by no means out of anybody's reach. In most boards' cases, it's literally just lay them on over the screw holes and put the screws in. This one has a nylon clip bit, which is an advantage in our minds, in that you don't need as many screws, and the board's a little bit more secure in the box.
Included in the box of parts that we get the rails for mounting the floppy drives and the other drive parts, and we get friction holders that will actually work to hold these in place so they don't vibrate. There are standard rails in case you work to a different case that come with some of the drives, and these come with the drive. We're going to put those aside because we're going to use this type, and it has a particular clips right in place. It snaps into place. The screws are 3 or 4 different sizes, and we're going to work the right size screws for this motherboard, and we'll attach that and put it in place. We have 3 screws of that size and 1 plastic mounted screw because it screws right into the plastic part of the chassis. And all it takes then is an individual with a screwdriver.
Okay, and again, I'm grounding myself before I go any further with this. Excuse me for a second here while I put that in.
Okay, and that finishes putting the motherboard in physically, and we can get a pretty good look at how it looks inside the case, and it's nice and firm. It isn't going anywhere. One of the things we want to be careful of is that these align with these open slots in the back, because when we place the cards in, they are going to wind up being aligned with the back of the slots so that the external component that we put on will be able to plug in.
Okay, last thing that we have to do to end up this piece is we have 2 power cords. They're labeled P8 and P9, and they plug onto the motherboard, and when we do that, the motherboard installation is complete. So we'll do that, and we're done.
These, incidentally, are the only 2 6-lead wires that you're going to find in the entire chassis. They're mounted side by side, and if there's black wires on both, the black ones go side by side on the mounting. You'll see that when Ernie finishes mounting those in.
Okay, let's go. Let's just break the segment.
Okay, and that finishes up this segment. mounting the motherboard, the first part of this is really pretty simple. So next time we come back, we're going to do a little bit more. We'll add some cards onto some of these slots, and we'll get ready to put some of the drives in the bag.
So we'll see you next time on this new PC.
Welcome back. Boy, it seems so easy to be able to do that.
Yeah, the guys, they did a nice piece, and we're going to see more of them in upcoming weeks.
They did a fine job.
They did an excellent job. You going to talk about this guy?
Okay, I will. One thing we wanted to mention that our second software winner from last year was Dan Bevan of Springfield. And we hope that he enjoyed the software.
I'm sure he did. I'm sure he did.
Yes.
We had a lot of nice titles, and we're doing it
Quite
again
a
this year.
package.
That's right. And this year, if you want, anybody who wants, we showed this in the past, we have the PC Voyage hit list on how to buy a PC. If you're interested in receiving a copy of this without the handshaking, just send us your name and address. Just send us your name and address, and oh, she'll drop it now. Send us your name and address, and we'll be more than happy to send you one. It'll also enter you into this year's drawing for software. And I guess we're going to go right now to the address.
Okay.
Hope everyone got the address. Is final wrap-up here. We hope everybody enjoyed the Cigna segment.
It was amazing, wasn't
And
it?
you did a great job out there.
Well, thank you.
For your first field report, you did an
Yeah.
excellent job. I also want to thank Ernie Savoy and Glenn Trim for the work that they did on this new PC.
Beautiful job.
And I think we're going to see more of those here in
I
the
hope
not too
so.
distant future.
I hope so.
And I guess that's about it. I'm Rainey Laviolette,
And I'm Diana McLean.
and we'll see you next time on PC Voyage.